Assalamualaikum. My name is Siti Nordini Binti Samson. My matrix number is TN210030. I'm from Group 2. So today I'm going to present about air flow through a Venturi section. So firstly, I'm going to explain about my objective. So which is for this experiment is to measure the distribution of total pressure and static pressure along the Venturi meter. So for theory, I'm going to explain about 3 points, which is first is the Venturi effect states that is in situation with constant mechanical energy. So the second one is the velocity of a fluid passing through a concentric area will increase and its static pressure will decrease. So the lastly point is the effect applies both the principle of continuity as well as the principle of conservation of mechanical energy.
Meter yang mana?
And then the repeated tube aeration and multi-tube monitor and also outlet.
Assalamualaikum. My name is Okay, so first you need to turn on the main switch. And the second is to turn on the main switch. Press the right. and then we turn off the main switch. Okay, next I will proceed about the result. After we get the value of x, h1 and h2, we can calculate the value of total pressure and also static pressure. The formula that we use to calculate the total pressure and static pressure is pressure equal to height times rho times gravity. Height is the h1 or h2, rho is the mass of density, g is the gravity. So by using this formula, we can get the true value of total pressure and also static pressure. Next is the observation. This experiment is divided into two pressures. The first pressure is static pressure and the second pressure is total pressure. Static pressure is the pressure in a homogeneous incompressible fluid in steady flow along a level streamline at points other than the stagnation point. Total pressure is basically defined as the hydrostatic force applied by a static fluid on a plane or curved surface when fluid will come in contact with the surface. The experiment's findings indicate that H1 represents total pressure and H2 represents static pressure. The statistics show that when pitot tube distance increase, the value of H1 decreases. Reverse for static pressure, H2 pressure increase as pitot tube increase.
So the last part is a conclusion. So conclusion is that in this experiment, a flow through a Venturi section has been used to successfully carry out an experiment in order to determine the distribution of total pressure and static pressure along the Venturi meter and to compare this with the products of Bernoulli expression. This measuring technique operation and characteristic was used, and by comparing pressure drop that will be calculated that related to the velocity of the fluid in the pipe. Although the experimental procedure was set up in a good and orderly condition, however, for the result in total pressure and static pressure, usually using the formula PGH or rho GH, P is the so the pressure can get the value. So that's all from me. Thank you.